Hi, nice to meet you. I know zero Russian, so I'm just going to assume Baruch was talking about how I work for Microsoft and have apples. Oh, that was a backup. Yeah, okay, so that's also another good joke, is because you can tell my ops background shows when I always have redundancy ready for live demos. Just in case, PowerPoint crashes, things happen. Anyway, how's everyone doing? All right, come on. It's like 4 a.m. in my brain. Let's try this one more time. How is everyone doing? There we go. That's how we know Java's been properly installed in our bodies. That's my dad joke of how we all drink coffee. And we're hopefully all well-fed. And if not, I apologize in advance, because I might make you hungry during this presentation. And you'll see why. So this is from Zero to DevOps Superhero, the Container Edition. And we have a lot of fun stuff we're going to go through. We only have about 60 minutes, and while that's longer or more time than I have given this presentation in the past, there's still going to be a lot to cover. So I want to make sure that we just have a disclaimer of what you can expect over the next hour. First off, this session was not designed to make anyone an expert. I can't do a brain dump and impart just every single thing that I did. However, the intention of the session was designed to get you thinking, to get you excited, to show you things that are possible, or maybe challenge your current way of thinking, and then give you resources where you can learn more. Anything that I'm going to show you is already available online. You're going to get a QR code at the end, so it's going to be my gift to you, and you'll be able to go off and play with this on your own time. So let's go ahead and dive right in. So I think it's no secret to say that life runs on code, especially for everyone in this room, right? We're all engineers. We all deal with code every single day. Our lives literally run on code, because if you're an engineer like me, even when I'm bored, half the time I don't even realize it, I'm suddenly back in my terminal. But what about the rest of life, right? Not just our jobs, everything that we interact with on a daily basis. That aspect of life also runs on code. And therefore, because we're engineers and innovators and supporters, we need to consider how, from a career perspective, we can scale to support this kind of life running on code. Now, take, for example, this car right down here. We call it a luxury car. We say that because, due to legal reasons, I can't say the actual brand of the car, but it rhymes with Schmeshla. And in the US, it's not as common. I know in European countries and overseas, it's a little bit more common to see on the road. But for a Schmeshla, cars like that use 120 million lines of code. I was actually surprised to see that that's more code than a space shuttle takes, which is 400,000 lines of code. So it's almost 5 times as much, which is just crazy to me. Now, for those of you that maybe your life doesn't have a Schmeshla or a rocket ship in your backyard, what about the rest of our interaction, the rest of everything that we do that depends on code? Take, for example, our urban traffic system, the traffic lights. When we go to the airport, the signs that alert us to roadway conditions. Any of that interacts with our traffic control or driving as we're heading to work or taking kids to school uses 5 million lines of code. Or, in the past few years, if you're familiar with open source software in the healthcare industry, or you've ever heard somebody who I work with named Scott Hanselman speak, and he's done a session on body hacking, where he talks about, again, open source software and code in the healthcare industry. This right here is actually a silhouette of Scott Hanselman, and it says that he has an artificial pancreas that uses 160,000 lines of code. For him, life literally and figuratively runs on code. 160,000 lines of code keeps him alive. And he's talked about this for the last 3 years, and then he's blogged about diabetes and all of this for the last 10. But the point is that code is in everything we do. Aside from having artificial pancreases or body hacking, aside from the urban controlled traffic system or Schmeshler or space shuttles, what about everything else? Any intelligent vehicle, pretty much any vehicle made within the last 10 or 15 years. Smart homes, right? The average home now, between Rokus, Apple TVs, Netflix, Hulu, Amazon Prime, iPod touches, Android devices, phones, kids, the average home has between 10 to 20 devices, just estimating, including smart TVs, or smart lighting, or smart doorbells, or smart locks, right? Code is involved there. Every single bit of digital life, even from a smart city, stadiums, concert venues, all of that has code. Malls, shopping centers, point of sale systems, any of that runs on code. So how, as developers or engineers or operators, can we support this innovation when it also dramatically affects the way of life for everyone around us, aside from the fact that we're just engineers? Now, just by a show of hands, how many people would identify themselves or feel comfortable identifying as a developer? Awesome. How many people would feel comfortable identifying themselves as an operations engineer? Perfect. We actually have a really healthy balance. Now, how many people wears whatever hat their boss tells them to wear? Everyone's hand should go up because we all should be listening to our bosses, right? When they can't watch YouTube at 2 o'clock in the morning, that's important. Just kidding. But aside from obviously life running on code, I'm also going to talk about this session on how life also runs, as we're seeing the industry change, on waffles. I told you I was going to make you hungry, and you'll find out why. So now for the developers, for those of you who raised your hand, perhaps some of these things sound familiar, right? For the developers, we often feel, and by the way, my background is I spent 10 years as a systems integration engineer and operations. So I was more on the systems administration, web management. Now I work on DevOps. I'm more on a development team. But I have a background kind of in both. So I'm kind of treading the line. So I can understand the perspective of both parties, whichever side of that you fall on. From a developer perspective, we need to create applications at a competitive rate without worrying about IT. And we all know the age-old saying, it works on my machine, it's your problem. Give me the keys to your server, I will take my zip disk, my USB disk, my floppy disk, my CD-ROM, I will take a hammer over, and I will beat that server until it works, because I know my code is perfect, right? That's our traditional way of thinking. So as a result, the developer mindset is that we're left feeling as though our productivity and our innovation become suspended because we have to wait on IT. What does that mean? It means that the developer traditionally has felt as though IT is the bottleneck to their success. Because as a developer, I am incentivized to move as quickly as possible, to be agile, to constantly push updates, to keep up with this life running on code constantly and quickly, right? But if I put my ops hat on, that changes a little. Because now I need to manage servers, I need to maintain compliance, I need to maintain corporate policy compliance with little disruption. But since I'm not natively a developer, I don't actually want to be a bottleneck. I want to work with you because I don't know how to integrate these unfamiliar applications. But I can't focus on both my server protection and my server security as well as the security of your code. So we have to find this happy medium. But the problem is, as an operations engineer, I am actually incentivized to work against you because my job is to keep the lights on, to make sure that there's as little change as possible so there's as little downtime. So if you think about it, again, traditionally, the developer and operations people are running headfirst into each other. They're constantly in competition to where one person wants to move quickly, the other person wants to move slow, and there's no moving in the same direction, which is not going to help us be able to sustain life running on code. So we have to see things from other people's perspectives, from our counterparts. That's where this slide comes in, IT stress points. And I love showing the slide because every time the developers in the room are always like this. Whew, that says IT. It's not my problem. It doesn't say developer stress points. No. I mean information technology. If you work in technology, if you write software, if you support software, if you support the infrastructure software runs on, however your role fits into information technology, these are our stress points. And therefore, they are our collective responsibility. We all need to focus on security. We all need to focus on efficiency. And we all have to support this innovation and this rapid life running on code direction our industry is heading in. In fact, Gartner and Forrester and a few other companies have done studies, and their estimation that 2020, which is just in about 2 months, is going to be known as what's called the ubiquitous era, where customers, rather than having a couple devices per household and consuming a couple of services or a couple hundred, are now going to be consuming thousands of services. Think of the apps you have on your phone. How many services or microservices or different applications you interact with, or your friends, colleagues, family, children interact with on a daily basis. This is rapidly growing, and as a result, this is the innovation we have to consider. That's why the topic of DevOps comes in, and then we'll see on how containers also ties to that. So I always want to level set the room and make sure that we're going off of the definition that my team stands behind and that has been published in several books. It was actually written by Donovan Brown, who I work for, but the quote is, DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Continuous delivery of value. If you're not delivering value, what are you doing? And why are you doing it? And more importantly, how do you know if you're delivering value? How can you tell? How can you gauge it? What telemetry, metrics, insights do you have in place? If you're already running Kubernetes in production, microservices, containers, web apps, do you have insights into what's running in your containers? What's running at every level? From your code, from your commit, from your servers? What kind of insight do you have to that value delivery? Because I can roll out all the agile changes I want. I can constantly push all the best features I think are going to work. But if the end users aren't consuming it, or if it doesn't work and the lights go off, am I really delivering value? So that's going to be a huge part of what we talk about. Containers help solve some of the problems we've identified, right? For both the developer and the operations person in the room. For the developers, it enables this write once, run anywhere architecture. It actually sets us up for microservices, right? And I'm not just talking about Kubernetes and container orchestration. I'm talking about, going back 5 years ago, a basic Docker container that I can put anywhere and I can put on any kind of cloud or run locally, right? It really sets us up. From an operations perspective, it gives me the ability to be portable. It gives me the ability to have standardization across every single environment. I no longer have to say, well, sorry, we just rolled this out to production. It worked in QA, but somebody updated Java on production. Now we have to roll back and make a bunch of changes. Now production is down, or flip the DNS over to a different live server. I don't have to worry about that because now I have that standardization. I also have abstraction. I have the ability to take advantage of higher compute density. I can vertically scale and horizontally scale. I can do so many things that I didn't have the power to do with traditional virtual machines or virtualization infrastructure. So again, this is also a superhero talk, right? From zero to DevOps superhero. So for those of us in the room that might have been snapped by Thanos' fingers, Avengers Endgame reference for you there, we're going to review what a container is. And I still think, even though it's been about 5 years now, I still think that this is incredibly important because I have conversations everywhere I go with the first line. It's not a virtual machine. I have heard people try to describe it. Well, it's kind of like a virtual machine. It is not at all. It is process isolation. At its core, it's not even a real thing. It's just an application delivery mechanism that has process isolation included, not complete isolation, right? We'll still have to consider that from a security perspective, but it's based on several Linux kernel features. So for those of us who maybe have a Windows background, certain things like namespaces and C groups might sound foreign at first. So the easiest way that I describe it is it's a waffle. And here's why. This picture is a little misleading because it actually has butter and syrup on it. So if we take that off and look at just the waffle, how many people like eating waffles entirely plain? Nothing else on it. There's always one, I swear. Man, I feel like I need to get you waffles. Now, how many people like all the other toppings, right? Whipped cream, strawberries, blueberries, raspberries, maple syrup, pecans, anything else. Everyone, right? I mean, I love this. This is why I CrossFit. Now, here's the difference, and here's why I say that a container is a waffle. Because all of those additional toppings are bringing happiness or value to our stomachs. All the waffle is the delivery mechanism for that happiness or that value. That's all a container's doing. If you don't have any additional value, doesn't have to necessarily be happiness, but if you don't have anything that you're delivering or you can't gauge that or you don't know, that's going to be where the challenge comes in. That's going to be what we want to help kind of fill those gaps or get you thinking. Now, let's make sure that we understand the differences between virtualization and containerization. There's two types of virtualization. You either have a hypervisor that runs on top of bare metal, or you have it that runs on top of your operating system. Maybe that's VMware, maybe that's Windows Server, Hyper-V, whatever. In any sense of virtualization, you still have your own individual virtual machine, your own self-managed set of dependencies, packages, Java runtime libraries, JDKs, JREs, whatever you want to call it. And then you have your application that ultimately runs on those servers. But they're all isolated. They're all different from each other. In a container, you actually have Docker, and this is the same even with Kubernetes. You have Docker that sits on top of the host operating system. And the Docker engine and the Docker socket is actually what underlines that. So when I'm running a container in any capacity, it's an encapsulated runtime environment. I have packaged that up. I have created almost something that's isolated. It's not fully isolated, right? I could still theoretically jump out of that container and attack the host, especially if I'm running that container as root, which I don't want to do, and we'll talk about that and talk about how we can identify that. But in that instance, now I can take that container and I can put it anywhere. I can run it in a web app, I can run it in Kubernetes, I could go back to 2015 and run it in Mesosphere. I mean, whatever you want to call it, right? I can sit there and put it anywhere. So that's one of the benefits from containerization because it gives me that abstraction. But with abstraction comes other things to consider. And I always review again how a Docker image works because I have reviewed with customers so many times where they still have database connection strings baked into their layers, personal access tokens, SSH keys, access to the entire keys of the kingdom, and half the time, not half the time actually, occasionally I have seen those images even be pushed to public repos, which now opens up a security flaw, a vulnerability flaw. Remember with your layers, anything that exists in your read-only, right? Anything that exists in what you're actually going to be running at your container layer can be accessed from the container layer. So we need to consider that. The other way I like to think of it is it's kind of like a cake or a stack of waffles. I couldn't find a good stack of waffles. I feel like I need to bake and add the whipped cream and everything. But remember, if I'm still working up at the top and I want to get more happiness down at the bottom, I can still go back down to the bottom and get my raspberries, get my blueberries, get my whipped cream. Or that means I can get my database connection string, my password, my production database password, my SSH key, whatever it is, right? I have access to that. So it's one of the reasons how come we really try to emphasize the power of multi-stage Docker builds or setting up your build pipeline to do build tasks prior to anything that you need at runtime. And we'll talk about that. Don't worry, I have a very code-intense demo coming up in one slide. So let's recap real quick, right? The container advantage. From a developer perspective, it now gives me this ability to iterate quickly, to have an agile delivery system, right? I can now move in that fast direction that we talked about. And it also gives me the ability to have something immutable. For the IT person, it gives me cost savings because I'm not trying to manage all these different servers or all these different environments, and I'm not working in a reactive way. I now have an efficient deployment that I know is going to work the same way every single time. And I have something that gives me elastic bursting, where I can go from the private cloud into the public cloud and vice versa. Now, if you consider the definition of DevOps and that our ultimate goal is the continuous delivery of value, remember the direction I talked about in the beginning for the developer and the ops person, that we were traditionally running against each other, right? Now, if I set value as the end goal, both of us can go towards the same goal together, and we can utilize different things that will enable us to achieve that value, containers being one of them. So in the demo now that we're going to go through, I'm going to show you how you can tie other things in to your pipelines, to your consideration, where we can start kind of playing with different insights that can help you gauge value and help you see things from a security perspective. So I'm going to end the show here, and I'm going to flip over to my browser. So we're going to go to this first slide here, and I'll make sure that we're zoomed in. So this application is a Spring Boot application, okay? It has Maven packages, standard Java, but I didn't write it. I actually started this, I think, almost a year ago. I started working with Baruch because we wanted to come up with something that was real world. One of the tools I'm going to show you, in this part, we're going to talk a little bit about Kubernetes. We're going to talk about Helm. Helm is the de facto package manager for Kubernetes. Now, how many people love writing Helm charts from scratch? If it's the same person that likes plain waffles, I won't be surprised. No? Oh, there. No, okay, now we have a new one. There's always one, right? Writing Helm charts or writing YAML files or tabs or spaces, all of that is challenging. And trying to write it from scratch is awful, especially if you're a developer. And let's be honest, do you really care about ingress controllers, egress controllers, networking? No. We don't care about that. We just want to know that our containers run. We just want to know that our code works. So in this demo, I took somebody else's code. And I specifically took a Java application with outdated Maven packages because I wanted something that was going to be the most complicated and something that I had no idea really what was interacting with. The only thing I knew was what port the application ran on and how much time it took to spin up. So I'm going to use a tool called Draft in this demo. And Draft is going to enable me to actually create my Helm charts completely from scratch. It's even going to create a Docker file for me. So if I put on my dev hat, and I've been working with my code, and I run my Java or my jar file locally, and that looks good, how can I be sure that it's ready for the container world? How can I be sure that it's going to be ready for a pipeline that's maybe emphasized with containers? I can test all of this out locally. In fact, if I zoom in, you're going to notice on the right-hand side here, I'm using Docker for desktop. I have Kubernetes running in Docker for desktop. I've done that by simply checking a box. So if I go to my Docker for desktop right here, I'll zoom in. We'll go to Preferences. You can see Kubernetes. And you can see I have Kubernetes 15.4. It's the only thing. I have that, Helm installed, and Draft. And Draft is open source. So we'll close this real quick. And I'm going to do two commands. The first command I'm going to do is I'm going to do draft create. And before I press enter, I just want to show you on the left-hand side here, I do not have a Docker file, and I do not have a charts directory. I don't have anything that's any kind of Kubernetes manifest or Helm chart or anything that says that I intend to use this in a container. So all I'm going to do is hit enter for draft create, and it's going to automatically detect my languages, what language extensions I have in my repo. Chances are I didn't write my application in YAML. Chances are I didn't write it in shell. But look, I'm detecting Java code. I'm ready to sail. Now, what does that do? That actually gave me a Docker file, and it gave me a charts directory, complete with a deployment template, an ingress template, a service template. So now, as a developer, I can go make the key minor changes that I care about, that I know about. I just want to test if this is going to run locally. The operation stuff and proxies and networking, all of that can happen afterwards with my DevOps team. But I just want to make sure this is going to work in a Kubernetes environment. So the first thing I'm going to do is I'm going to take a look at the Docker file. Now, if you notice, the Docker file is actually a multi-stage Docker build, right? Because often what I need at build is not what I need at runtime. So in this instance, I have my JDK as my build, and then starting from line 6 is my actual runtime environment. That means I can put anything I need in the first stage, and then it'll just copy over that published jar file from my second stage. Now, the first thing is I need to change the port because my application runs on port 8080, so I'll make that change. And I know that when I actually bundle all this, I don't have anything that has a dash with dash dependencies. So I'm going to clear that out. We'll zoom out, and I'll hit save. Now I need to go over to my charts directory. And for those of you that are maybe new to Helm and don't understand how it works, you have something that's called values. And so you have a values file that any of your templates, your deployment template, your ingress template, your service template, all of those are going to use parameters to reference whatever you define in values. So take line 9, for example. That's replicas. Replicas equals values.replica count. So if I go over to my values file, you'll see right here on line 4 is replica count. So I can control all of these templates, all of these parameters and variables with one YAML file. I'm no longer having to play with tabs or spaces or trying to remember the name of which service, which label, which port. I can just do it all from one master document. So I'm going to change the internal port here to port 8080 to line up with what I've said in my Docker file. I also have, by default, because these Helm charts that are given to you are based on best practices. I have resource requests and limits. Here's where I can set how much access this application, this Waffle, has from a process perspective. How much memory does it need? How much CPU usage does it need? I can define the bare minimum and I can define the limit. For both of these, I'm going to set it to the same. So I'm going to use find and replace. So I'll copy, I'll just go to find. I'm going to do 100, and we're going to change this to 256. And I'll go ahead and just replace that. And then I'm going to do the same thing with 128, and we're going to change this to 512. And I'm going to hit save. That's it. That's all I'm going to change, and that did not, 128 did not save. So we'll go back over here, change this one more time, 512, replace. There we go. And now I'll hit save. So that's all I'm going to do. All I did was change how much resources my application need and the port. Now I'm going to clear the screen, because I do like working with a clear screen down here. And I'm going to do the second command, which is draft up. And what this is going to do is actually going to build my Docker image, and it's going to release it locally into that local Kubernetes cluster. Now, this will obviously take some time, because it's going to have to go through and build the jar file, the Maven packages, and all of that. So after I do those kinds of things, I can make additional changes. And maybe this is me working in an environment within my DevOps team. Maybe I'm working directly with my operations person. But if I'm going to be doing best practices, I need to put this container image in a secure place. I need to put it in a highly available private registry. So I'll create an image pull secret, right? I'll go down here, and I'll add in the code for an image pull secret. I want to make sure that Ingress is enabled, maybe networking, right? I want to make sure that I have a TLS certificate that's automatically issued. So I set all these things. Again, this is maybe working with ops. These are things that maybe we don't directly care about, but they're minor changes we would take to bring it cloud ready. Maybe to also know that I want value, I'm also going to add an application insights key. That's going to give me direct information, the same way I would have if it's running just in a zip package in a web app service or in a container. I'm going to have actual real-time metrics of what's happening in the application. Notice how we're moving in the direction of value, where we're starting to have insights into what's going on, and we're starting to manage it maybe from more of an infrastructure perspective. Again, not so much of what the developer cares, but for the operations people now in the room, we can start working more closely with our developers. We can start moving together in that value-driven direction. Anything that I have in values has to also exist in my deployment YAMLs. So I'd come over to my deployment YAMLs, and under container, I need to make sure that I add in my value pull secrets. Now, the cool thing is it also recognizes if. So I can say if values image pull secrets is defined, add this snippet of YAML. I can even make sure that I set my environment variables. So I'll just make sure that it's indented properly, but you can look. Environment variable is application insights, and it equals values application insights dot instrumentation key. Every period you see is an indent from your values file. So every time you have that tab or that indentation, it's just a sub-indent. So I'd save that. Then I go over to my Ingress. Now the default Ingress, you'll notice, is actually pretty basic. If you have familiar with Helm charts already, there's virtually no metadata. I don't have any ability to do annotations. If I scroll down, there's nothing for TLS, right? I don't have really anything. But for the operations people in the room, I can make just a few changes. For example, I can add annotations, and because of the way Helm works, it'll actually allow me to pipe over to an automatic indent. So when it actually renders this manifest file through the Kubernetes API, it'll be properly formatted. I can do the same thing where then I say if values ingress TLS exists, set up the TLS secret. And I can do all of this just from making a few changes with one base template or scaffolding that Draft gave me, right? So now I can work with you and with the developer. We can both work together. So those are the only changes I would have to make it cloud ready. Let's take a look at actually testing it still from the developer perspective now that this built-in released. You can see it took about 58 seconds to build, and it released it locally. So I'll go ahead and clear the screen again, and I'm going to do a k get pods. K is an alias for kube control or kube cuddle. In case you're not one of those people that enjoys cuddling with your command line, I just make it K because now I make everyone happy. No one can argue. And you can notice that I have the Spring Boot WebSocket application. It's been up and running for 2 minutes and 41 seconds. I can do K get services, And I can see that the service also has been running for 2 minutes and 57 seconds. Now, if I'm familiar with Kubernetes, I could port forward, I could tunnel, I could try to figure out how I could test this, again, from a developer from locally. But draft gives me a bonus command. So I'm going to clear the screen, and I'm going to type draft connect. That's actually going to create an automatic proxy without me having to do anything, port forward, play with labels or services. It's going to create the tunnel for me, and you can see right here where it says you can connect to your application on this local host. So I'll scroll back up, and I'm just going to grab this local host address, and we'll zoom out here real quick. Flip over to Chrome. I'm going to paste this in. Now I can see that the application is working. And just to show you, again, I'm just using localhost. This is me testing from a development perspective. And I can type in my username, start chatting. Hello, St. Petersburg. That looks lovely. Everything works. But now I need to figure out, again, that value add about getting it out. Now, it's not so much about whatever CI/CD or DevOps stuff you use. The spoiler alert from here is what is wrong with the base code that it gives you. Let's start off with the Docker file. The first problem I see is, remember how important I told you that runtime image is. Not only about SSH keys or PAT tokens or different layers of the cake. I'm using a public image. I'm using an image where I have no idea what's in that. On top of that, that container is running as root, which violates a corporate policy. So now we start thinking that regardless of if you use Azure DevOps or Jenkins or another CI/CD specific Kubernetes tool called CodeFresh, or I already said Jenkins, or Travis CI, or TeamCity, whatever your DevOps server is, we already know the basic tasks. We're going to build, push, Helm lint, Helm package, deploy. And we can deploy to our different environments. But what about the in-between? How do I figure out what's running or if I'm violating corporate policy? I'm going to answer that. Because before I got here, I actually already did a deployment with this code. So we've already pushed it, we've already committed it, I'm already running the JRE, quote unquote, in production. But I used also JFrog Artifactory and JFrog Xray. So Artifactory allows me to make sure that the private packages I have for Maven don't have any vulnerabilities, don't have any malicious code or Bitcoin mining software, anything like that. But I tied it over with something called Xray. I could do the same thing with Aqua, with Twistlock. I can do that from a container perspective. Xray gives me the ability to have actual binary investigation even in my packages. So I can drill down into this Xray scan report for this particular build, and you can see that I have a high alert right here. I have 6 different violations, and I have 40 different security concerns. Now, a lot of these are that it's running in Debian, it's running again in a public image. But another thing, if I'm using, again, different checks, I'm using things to make sure that it's within corporate policy. If I take a look, I'm going to have to refresh this, but this is my Jenkins server. We'll log in here real quick. If I take a look at my actual Jenkins instance for this build, you'll notice that it failed on my Aqua security scan. And if I drill down into why, by going over to the printed report or the history of what happened, I can see that it actually was a non-compliant image. And my image assurance is that I need to create a non-root user for the image, right? So all of these tools are helpful things, or only as good as your ability to deliver value. You're not delivering value if something is non-compliant, if something has malicious code, if you don't even know what packages are running. I've been doing this same demo for, again, almost a year, and every single time I have to run through because my POM file needs to be updated. The Maven packages need to be make sure that they're patched and constantly in alignment with the policies that we've defined. And I'm able to see that because of these pipeline checks or tasks that we've added in. So let's go ahead and make a change. I'm just going to go ahead and update this Docker file. And you'll notice I'm adding 2 lines. I'm changing an image to one that I own, and I'm setting my user to a non-root user. Those are the only changes I'm going to make. I'm going to save that, and I'm going to check that in. And we're going to do a live patch on stage. So I'll say update Docker, and I'll go ahead and commit, and I'm going to push. Now, I want to show you a little bit more from the Xray scan report. Not only can I see exactly the violations and I can see the security concerns, I can also see the location information. I can see where it exists. I can see where the packages exist. Now, I could drill down into that and start clicking a bunch of tabs, or because of the way I set up the pipeline, I can go into the Slack notifications for build artifacts directly. You saw Azure pipelines in there as well. I'm using several different tools just to show you that it's not about the tool. It's about the security. It's about the checks and balances. It's about the value. So let's go ahead and log in here. And I can see all the different published modules. I can drill down into the actual artifact itself, and I can see any dependency information. I can see that this is actually my Helm package right here. If I zoom out and I go back one, and we go into the actual Docker image, I have the Docker image information for my artifacts, right? I can see any information that's relating to the build. Now, I want to talk about the pipeline. I want to talk about how this is getting all that information, and the reason why I chose Slack. The only way you, as a developer, operations, or DevOps team, are going to know if you're delivering value is if you're all on the same page and you're all speaking the same language. So if we take a look at, let's say, Azure DevOps, for example, we already talked about the tasks we know we need to do, right? We need to do Docker build, Docker push. So I make sure my build server has Helm. I lint my Helm chart that I built using Draft. I package it up, and I put it somewhere. Maybe that's Artifactory. Maybe that's Azure Container Registry. Maybe that's Google. It doesn't matter. And then I build my image. In this instance, I use Aqua to do image scanning, and then I push that image somewhere. This pipeline is missing having a private package feed, but ideally that would also be included. Maybe that's included directly from my POM file. And once I've done that and deployed that, I can get an image scanning report once I know that it's clear, that the image is allowed. I can see vulnerabilities that exist in which package. I can see different layers. I have insights into that. I can do the same thing, again, if it's over in Jenkins. If we take a look at the different tasks that it was doing, which is currently building, but it's going to go through and it's going to test my deployment. It's going to package it. It's going to upload. It's going to build. It's going to scan. I'm going to show you CodeFresh, which is, again, specific for Kubernetes. And let's take a look at what this one's doing. This is using JFrog to build. So that first stage we talked about is actually happening outside of the container, because all I need is the jar file. And then my second stage can copy from my build server that jar file and do everything else. It's still a secure way to handle it. I build my Docker image. I promote it. I package up my Helm chart. I actually then switch over to test real quick to lint that Helm chart. I publish my build info to Artifactory and Xray. And then I actually send the information of my security scan. In this instance, I use Xray. I send that to Slack. I do the same thing in Azure DevOps, by the way. There's a command line task that does the same thing. In any of these instances, the tasks don't change. So your CI/CD process doesn't change. The difference is the insights and the telemetry into what's running, where, and how secure it is what you're focusing on. So if we switch back over to Slack and I scroll down here, it looks like the scan report completed. So I can drill down into that Xray scan report, and we'll let that open up, and we'll see how many of those violations I was able to resolve. First off, I now have 0 violations, so now this is a good image. And I went from 40 security concerns down to 2. Because I own the image, I now no longer have an image running as root. I now have something that has no issues. In fact, if I even go over to Aqua, and we'll log in here, we'll do it from another perspective. And the only way I can patch these things, by the way, is by knowing what's happening, by having tools or insights that tell me what's going on. So I can go to the CD scan, and you can see previously, which was, again, right before I came here, previously I had something with 4 high security issues, 11 medium concerns, 1 low. I had something with problems. Now, just from that patch, I was able to say that the image is approved, the vulnerabilities are no issues, there's no sensitive data, there's no malware, nothing, right? I was given a greater detail from a risk management or vulnerability. I have the same information over in Xray. And even cooler, I can go back over as soon as this finishes, and I would be able to approve the build. So we'll check on the status of CodeFresh right here. Looks like it's doing its security scan right now, which was update Docker, and I would be able to get a nice little approval button. Now, just for the sake of time, once this works, this ends up pushing out, again, the same thing we saw locally. I'm refreshing this. I'll type in my username, start chatting, and I see the same exact code that I had locally. I went through, granted, some of this stuff I set up a little bit beforehand just for the sake of time, but this was the same draft file, the same POM file, the same Maven package artifactory. Everything that I used locally, I was able to add in as part of the pipeline because I had the insights and the knowledge of value. So let's go back over to PowerPoint here and recap. let PowerPoint go ahead and make that switch real quick. There we go. So I started off with the first pipeline I showed you was just the task runner. And for those of you who don't know, Azure DevOps was formerly VSTS, and those tasks you saw lined up on the left are just standard tasks I would run. It's the same thing that I would define in Groovy using Jenkins, or YAML using CodeFresh, YAML using Travis CI. The tasks themselves didn't change. So I had a Kubernetes pipeline, but we saw the spoiler was that I actually had 3 different pipelines that were all doing the same thing. Right? I'm building a Docker image, I'm pushing that to a repository somewhere, I'm having some sort of package scanning, image scanning, corporate policy compliance scanning, and then I'm deploying it. And I only make that deployment if it meets the security standards. You saw the red before. Obviously, I get, number one, I can have it immediately fail the build and say absolutely don't allow it, or if it didn't fail and I want to make sure it's not a false positive, I can even set up deployment approvals. I can set up gates. I can set up other parts to my process, and I can deploy it to any one of those standardized environments. Now, let's go ahead and just recap. For those of you in the room that, again, were snapped by Thanos' fingers, which conveniently works out on the 5-year time frame because Kubernetes is 5.5 years old, Kubernetes is an open source container orchestrator. It was designed to automate deployment, scaling, and management of applications. It was originally invented by Google, and it was based on something called Borg. Google has been running billions of containers per week for over 10 years. This isn't new technology, but the way that we're approaching container technology from a security perspective and value-driven perspective is a lot more popular in the last few years. So if we think of the core of what Kubernetes was designed to do, it was designed to simplify. But as we know, when we deal with Kubernetes, when we deal with Helm, when we deal with containers and abstraction, things don't get more simple. They get more complicated. So how can we add simplicity when we consider DevOps? How can we add in those tasks that's going to allow us to keep things simple? That's where Draft comes in. That's a tool you can use to simplify the Helmshark creation. And as we saw, I can use it whether I'm a developer or whether I'm ops. And all I have to do is make a few little tweaks, and I have something, I have a framework or a foundation to work upon, and it complements the de facto package manager, known as Helm. And Helm was originally designed to be an on-ramp to Kubernetes. Helm actually just this week, just yesterday, I believe, hit its RC stage for version 3, which removes Tiller, and that's a completely different talk. But Helm itself, Helm 2, which is the current production use case or general availability, was actually a merger of Deis code and Google code. So the reason why I mention that is all of these things were designed to kind of be simple, but they weren't designed to be secure. We're starting to see, again, security added into Kubernetes. The creation and release of Helm 3 was with a focus driving on security because Tiller and giving access to everything in God mode wasn't secure. So we're starting to see this shift in the industry, and as those of us as developers, operations engineers, those of us who wear whatever hats, we need to move in that same value add and security driven direction. Now there's a lot of different tools or products you can use, but remember the definition of DevOps we started off with. It's the union of people. We've talked about you and everyone in this room. We've talked about process and the different tasks you can add in, and then it's about products. Whatever product is going to enable you to continuously deliver value. I get asked all the time, which product do I recommend? The answer is always the same, and it's never the same. And what I mean by that is I can't tell you. I can't tell you what I recommend because I don't know what's specific for you. So that's always going to be my same answer, but that means that after we drill down into what's specific for your enterprise or your environment, I'm going to have a different answer because it's going to be what is specific to your value delivery, what is going to enable success for your customers. The important thing isn't so much the product you use. It's the reason why you use it. It's the value you're getting behind it. So this is where it comes into my saying of KISS. And if you're familiar with the band, I'm not talking about the band. If you're familiar with I think this might be a United States saying, but the last S means something different. And if you're thinking of calling your neighbor a name, that's not what I mean either. I mean, keep it super simple. Go back to the core. Go back to your intentions. What is going to deliver value to your customers? If we think about it, and this is to the entire Kubernetes community, and this is the other spoiler of a containers talk. In order to be a superhero, you need to not know everything there is to know about containers and Kubernetes and YAML and all of this. You need to know when to not use the tool. You need to know when you're using it, why you're using it, when you should and when you shouldn't. I love this particular tweet that was originally by Abby Fuller, and then Kelsey Hightower, who is considered one of the godfathers of Kubernetes, even retweeted it. Not everything needs to be a CRD. If you're, again, new to Kubernetes, that's a custom resource definition. I talk to people all the time that will try to write their own CRDs, and they don't even know why. They also don't know what they're doing or how to protect it from a security perspective. They're trying to write their own operators, their own versions of Helm. They're trying to do a lot of things on their own. Number one, you don't have to do that. Not everything needs to be an operator or a CRD. And I'm going to add something to this. Not everything needs to run in Kubernetes. Sure, containers are valuable. That's one of the things that we've talked about. But really, we need to figure out why you're running it. Should you run it in Kubernetes? Maybe you can run it as a web app, or maybe you can do it as Docker run in the cloud. From an Azure perspective, we call that Azure Container Instances. Google, I think, calls it Google Cloud Run. Amazon has their own. Every single cloud has their own version. You can do web app, you can do Docker run, you can do Kubernetes, but you need to know why. And you need to know why you shouldn't at the same time. Again, superhero talk. So I'm going to now quote Agents Marvel of S.H.I.E.L.D., Gemma Simmons. The steps you take don't have to be big. They just have to lead you in the right direction. So often I hear people saying, okay, I saw this great talk, or I saw Kubernetes, or I saw a draft, and I'm going to go out and deploy all of this right now and have this running in production. In fact, I've known big companies and big news media outlets that have said, oh, Kubernetes is awesome. I'm blowing everything else away and deploying it into production, which, true story, they did almost 4 years ago, directly before the United States election, where they went and moved everything over to Kubernetes. Luckily, that ended up working out for them. But that's not realistic. That's not everybody's world. You don't have to take giant steps and run to the end of the race. You just have to make sure you're going in that right direction for that value delivery. Some questions you can ask yourself and ask your teams, whether those are your DevOps teams or your site reliability teams, which really they should be in those postmortem meetings together. These are questions you can ask your teams to help you figure out if you're moving in that directive. What are my main objectives? Where am I trying to go? What am I promising my end users, right? What is the main thing that's going to deliver value? What are my indicators, my key indicators for those objectives? How do I know if I'm delivering value? How do I have any kind of insight, telemetry, data-driven analysis of my pipelines? How can I have those indicators of whether or not I'm meeting those objectives, whether or not I'm taking that step in the right direction? I told you the spoiler, obviously, of the CI/CD part of the demo is that it didn't matter what my CI/CD system is. The steps itself didn't change. You can fill in the blocks kind of as you figure out what your pipeline will look like. For standard, maybe Kubernetes development or even just container development, in any sense, we know we're going to have to compile our code, right? Then we're going to build and push that code somewhere. We'll push it to GitHub. We'll push our Docker image over to some sort of private registry. And then we're going to run some sort of scans. And that's not only security scans. That's functional testing. That's visual testing. That's UI testing. That's code coverage testing, right? We start scanning. That's probably even part of our build process. Should be. And then we move on to maybe our deployment stage. After we've made sure those scans are correct. We deployed a test. We deployed a dev. We set up gates or telemetry or approvals or some sort of checks and balances before we move on. And we go into our different environments. Staging, QA, prod, canary, AB, blue-green. Doesn't matter. Your process is going to look probably similar to something like this. So then you just fill in the blanks. From compiling, especially when I'm doing something with Java or NuGet or pip or whatever you're dealing with, whatever language. I know typically JFrog and Artifactory, and I think this is a Java user group, so we'll focus on Maven. But you're going to want to use some sort of private package feed. I want to make sure that I control those packages just as much as I control anything else in my pipeline. I'm going to have a private repository. Again, something that I control. I'm going to have some sort of also security scanning in addition to my functional tests, my visual testing, my UI, my code coverage. And then I focus on the CI/CD. Maybe I also add in additional deployment tests, right? Maybe I do some additional Selenium tests after it deploys. Maybe I add in, there's other companies that also do, like I said, visual testing afterwards. You can tie that part into your deployment process. And you go back over to CI/CD. But you kind of just start filling in the blanks. No matter what you choose, the foundation is the same. And your end goal is going to be the same, which is going to be the need for value. One of the best questions I think you can ask yourself is, does this add value, or does this add unnecessary complexity? I'm a huge fan of making sure everyone on a team always knows what's going on, which is why I chose Slack as a communications channel for the demo. And I originally had this great idea where I was going to write an Azure function, or whichever cloud service you want to call, and I was going to write some sort of serverless application that could get the information from Artifactory or Aqua and then send this over through a bot and post all this stuff. And you know what I realized at the end of the day? That added unnecessary complexity. So the whole way I'm posting that message is through curl. And all I'm doing is just posting an HTTP message. That's it, through a webhook, right? It does the same thing. It gives me the same value, but it takes less complexity than I was originally intending. One of the best things you can do is, at the end of the day, remember that it is just a waffle, right? It is just an application delivery mechanism. Your end goal is to deliver that value, that happiness. Focus on that end user and what you're trying to offer. And again, I apologize if I'm just making everyone hungry. Now, there's always that one person, right? Of course, we've identified at least 2 people in the room that like eating waffles plain and like writing Helm charts on their own. There's always one person that says, okay, all that stuff's great, but I like to be in control so much that I'm going to do all of this by myself. I don't want a cloud provider. I don't trust any of these other companies to do scanning or images or anything. I have company proprietary stuff. I have my own data centers. I'm going to manage Kubernetes and operators and every other part of this. I'm going to do it on my own because my company has the investments, or I think this is a good idea. There's always one person that, at the very least, even if you don't want to go that far, you want to do one part of this on your own. So I have footage of what happens in real time when you do that on your own. Some of you might have actually seen this video before and you don't even know it, okay? So we're going to watch it. This is, again, real footage of what happens when you try to do things on your own without having additional help and additional insights. Uh-oh. Things start getting out of control. You have all these people around. Oh, I want to step in. I don't really know if I should. Oh, it's possibly going to take out a jet, or maybe a production server, or maybe something in real time. Maybe it's a company. I'm going to think of potentially US companies, but Home Depot, Experian, things that have had very public situations. And then here comes a savior, somebody with an answer, somebody with value delivery. Let me go ahead and help you stop the chaos. That's the goal of delivering value. We just want to make sure that the chaos stops and whatever you're doing is moving in the right direction for your customers. Now, the last thing I kind of want to touch on is, before you ever even get your code into a repo, maybe that's GitLab, Bitbucket, GitHub, I don't care. What happens in between? We've talked about processes, we've talked about tools that you can use and products that you can scan, but there's one thing that we really haven't identified, and that's human behavior, right? We've talked about how people check in personal access tokens, SSH keys, database connection strings. In fact, I'll be the first to admit it. I've done it. I'm sure other people have. How do we stop that? We know that we can scan for it, but what happens between I press git commit and git push, and then now my pipeline starts off? There needs to be a barrier in between where we have insights into that level of security. Maybe that's Docker running, maybe that's code, maybe that's packages. We need some sort of insight into that. There's credential scanners, there's other managers, there's other open source products. One that I'll just talk about today, just because I love the report that it gives, and it's free, is called Tree. And I just recently started getting a report. In fact, I was in a meeting, and they said, oh, hey, let's go ahead and connect this over to your GitHub account. We'll give you a full report of everything that's happening in your public repos, or in your private repos, by the way, as well. And here was my report. This is a direct picture. 31 people have access to my organization. I have 144 code components and 59 repositories. But now I have a direct report of everything that failed. I have the fact that I need to separate credentials from my source code, which that was intentional, by the way. I don't just keep credentials in there. Separate dependencies from source code. I can also set policies of making sure those dependencies have a version. Separate personal config files. Maybe those config files have database connection strings. Make sure git ignore. There's so many other policies that I broke. In fact, I got a full report of everything that I can see. On the left-hand side is just a catalog overview. I can drill down even more where I can actually set organizational rules. So this one was really cool because I can set policies that Docker from should have a tag and it shouldn't be latest. I can say that the Docker from actually needs to be an image that I own. It can only come from this repo. I can start setting all of these policies, and from there, it wouldn't even start the pipeline. It would stop right at Git and says, this is not in compliance. This does not meet policy coverage. You are not allowed to commit this. You're not allowed to check this in. I can do the same thing with user property, shouldn't be root. We saw that in Aqua. That complements anything before now you've spent 10, 15, 20 minutes at whatever part of your pipeline that Docker build happens. Why waste time before you find out that you did something wrong? You can get that information a lot quicker. You can set health check properties, apt installed. You can define any policy you want. In fact, I love this one. Stop using Python 2. Yeah, that's always a good one. And it's funny because it's a joke, but I know so many public projects that are still using 2.7. Security concern. How are you going to start thinking about that? So these are different things that we kind of want to recap. We only have a few more minutes, so I just want to make sure I cover some best practices we talked about. Focus on multi-stage builds or anything that you need in build being maybe as part of your pipeline in a secure way. Passing secure variables or secure secrets, right? Don't publish that at runtime and have some sort of insight into what's running in your repos. Having something that can give you a report of the actual health of your code prior to any other CI/CD. By the way, that took a whole 2 seconds to set up. I literally went to GitHub, I signed in, I gave it permission, and it did the report where I then went like this. Dang it. Oh, man, bad example. Application architecture is another thing you want to consider. Use namespaces. Focus on isolated environments, right? Make sure that your namespaces are locked down, maybe to RBAC and different service accounts. Not everything needs God mode. Use Helm charts. It is a best practice, and it will simplify your life. And if you genuinely enjoy writing Helm charts from scratch, more power to you, but find other ways to simplify that. Scaffold is another tool. Just the on-ramp is a little bit more complicated. So I really like Draft. Implement health checks. We didn't talk too much into this, but there was a little bit on the tree side where you want to set a health check property. Make sure that you have liveness and readiness probes, right? Make sure that your container is up and running. Kubernetes scheduler, especially if you're running in Kubernetes, will check for that and will restart the pod if it's not. You can set resource requests and limits. We talked about that. And then finally, be mindful of your services. Not everything, as we talked about, needs to run in a container and needs to run in Kubernetes. I'm definitely of the belief, though I have been persuaded to reconsider, but I'm of the belief that, again, keep things as simple as possible. Don't overcomplicate. Maybe from a database, do you really need it running in Kubernetes, or could you use database as a service? You can still connect that over to your Kubernetes microservice or your entire collection of microservices, right? I can utilize external services, external storage. Finally, and I always get asked about this, is don't rely on load balancers. They're expensive from a cost perspective and a time management perspective. You can use other tools. You can use application routing, Nginx. Nginx is the backbone of pretty much most application routings. But you can use, there's so many other different things that you can use in addition to just load balancers. It'll make it a lot easier. Finally, thank you very much for having me. This is my first time in Russia, so thank you. I tried to come last year, so I'm so grateful I get to come this year. I'm here because I love technology and community. At the core of everything, I'm an engineer just like you, so hanging out with other amazing engineers, it makes my day. No relation to James Deen, which means my last name is spelt with 2 E's, so you can connect with me online through whatever your favorite platform is. And then finally, here is my gift for you, where you can scan the QR code, or you can go to aka.ms/JLDeen with 2 E's / waffle ops. And thank you very much.